All right, these are some notes on section 3.2. And so what we're talking about more is how to graph these polynomials. And we're going to use certain criteria to help us figure out what we need to do to graph them. So one of the things that we're going to be looking at is the idea of the behavior on the left side of the graph and the behavior on the right side of the graph. So if you look at the chart that's at the bottom, this is from your book. This chart is very confusing. And so basically what happens is that you know that a curve that's x squared is going to be a parabola that's opening up. Okay, and you know that a curve that is negative x squared is going to be a parabola that's opening down. So, and you also know that x cubed is going to be a shape like this. So when we talk about the left behavior and the right behavior, on the left behavior for this one, we're talking about it being down on the left, and the right side of the graph, we're talking about it being up. And in this case, we're talking about it being up on the left and up on the right. And on this one, it's down on the left and down on the right. So if I put a negative in front of that x cubed, it becomes like this, and then we would say it's up on the left and down on the right. So what happens is if the power is even, 2, 4, 6, 8, then it will be up and up or down and down. In other words, they're both going to be in the same direction. Whereas if it's cubed or fifth power or seventh power, then you're going to have opposite actions. So when we look at this graph here, we've got x cubed. So because it's cubed, we know we're going to have a down on the left and an up on the right. This one's x to the fourth power, so that means that we're going to be up on the left and up on the right. This one is negative x cubed, which means we're going to be up on the left and down on the right. And this one is negative x to the fourth, which means we're going to be down and down. So when they're asking us to find the roots, they're asking you to find your zeros, and they said to use your calculator. Now on this one we can factor it and we can find our zeros. On this one it's a little bit harder to factor, but we can put it into our graphing calculator and we can see our zeros are -2, -1, 1 and 2. On this one again we can put it in our calculator and find our zeros. And we can also use our calculator to maybe find another point or so to figure out what it's going to look like. So the biggest thing I want you to see here is that this x cubed tells us that this graph is going to have a left behavior down and a right behavior up. And this x to the fourth tells us that we're going to have a left up and a right up. This negative x cubed tells us that we're going to have a left up and a right down. And this negative x to the fourth tells us that we're going to have down on both sides. And so we're going to build on this some more today. All right. So another topic that they cover is the idea of absolute minimums and relative minimums. And we've talked about the minimums and the maximums before, but on these graphs that we're going to be doing, we're going to have multiple minimums and multiple maximums. So like on this particular graph, you'll look here that this is a minimum, this is a maximum, this is another minimum, a maximum, and another minimum. Now you'll notice that this left one, this last one here on the right, is the lowest point in the graph, so we call that the absolute minimum because it is the actual smallest. Whereas these two are minimums, but they're not the smallest, so they call those relative. Now in this case, we have relative maximums, but we don't have an absolute maximum because this graph continues on in both directions forever. So we don't have any absolute maximums, we just have relative maximums. Okay? So this next concept is talking about even and odd powers. And this is going to be crucial to help us decide how we're going to be graphing these graphs and what the behavior is of the graphs. And so on this first one, we're going to factor our problem, and we get x plus 2 and x plus 2. And that can be rewritten as x plus 2 squared. So what this says is that if the power is an even positive integer, then that means that it's going to intersect, but it's not going to cross at that point. And if it's an odd power, then it's going to actually cross. So here's what we're talking about with this. So here's our calculator, and we're going to put in the x squared plus 4x plus 4. And we're going to graph it. So let me go back out to this. Oops. Alright, so when we look at our graph, we can see that it's touching at -2. So we look over here and we say our root is -2. So at -2, the graph is touching, but it is not going through the graph. So we refer to that as, since it's an even power, it's going to touch at -2, but it's not going to cross at -2. So we can use the same things here. So our root is -3 on this one, our root is 2, and our root is 4. Since the power on the 3 is 1, it's an odd number, it's going to cross. Since the power on this one is 2, that means it's going to touch. And since the power at 4 is odd, it's going to cross. So let's look at that one, and I'll explain it a little bit more. So I'm going to put it in my calculator exactly like you see here. So you have x plus 3, and then x minus 2 squared, and then x minus 4 squared, oh, sorry, to the third power. And we're going to graph that. So most of the graph isn't important. What I want to look at are these 3 points. So here's our root at -3. And notice that at -3, the line is crossing through the x-axis. At the root 2, here's our root 2, notice that it is touching there, but it is not going through at 2. Okay, and at 4, here's our root 4, it's actually crossing through at 4. So this can help us to know what the behavior is going to happen at those graphs, and whether we're going to bounce or whether we're going to actually go through and make a straight line. Alright, so let's look at this last example. And again, we're going to have x plus 2. So our root is -2. And then we're going to have x minus 4. So our root for that one is 4, and we're going to graph that. So our root is -2, and it should be touching at -2. And our root is 4, and it should be crossing at 4. Let me make sure I type this in right. I did. And so we're not getting a very good graph here because I think it's just the level of precision. But if we go to our table to confirm it, at -2, you'll notice that it is 0. So that does confirm it. It's not a very good graph. But again, what's happening is that it is touching at -2 and coming back down. But here at 4, it's actually going through the graph. So again, this helps us to come up with a better picture of what our graph's going to be looking like. So another technique that we'll use, and this one isn't quite as useful as some of the others, but this is what they call an intermediate value theorem. And what we're trying to do is verify if there's a 0 between 2 points. So if I wanted to know if there was a 0 between -5 and -3, so if I substitute -5 into the graph, into the polynomial, and then I substitute -3 into the polynomial, when I got -5, the solution I got was -30. And when I tested -3, the solution I got was 12. So if I look at my graph, and at -5, here's -5, and here's -3. At -5, if my graph is down here, and at -3, if my graph is up here, do you agree that somewhere between -3 and -5, there's got to be a 0? So the question is to verify that there is a 0 between these two numbers, and we have. We know that there's some 0 in there. Now, I don't know if it's -4. It could be some other 0. It could be -3.6. We don't know what the 0 is, but we can verify that there is a 0 between those two values. Again, not quite as useful as some of the others, but it does help sometimes. So here we want to verify that there's a 0 between 1 and 2. So we put 1 in, and we get -2, and we put 2 in, and we get 4. So again, since the values of these two are opposite signs, that means that there is a 0. So between between 1 and 2, okay? So at 1 it's -2, and at 2 it's 4. So somewhere in here there's a 0. Again, we don't know what it is, but we know that there is a 0 there. So basically for all these problems, we're going to have a series of steps. And this is what we're going to be always doing. So first of all, remember that I can call this a factor. I can call it a solution. I can call it a 0. I could call it an x-intercept. And we've talked about this before. So you need to be familiar with all the terms and the different ways to write the answers. So here's our procedures that we're always going to do. We're going to go through an example. First step is determine far left and far right behavior. Is it down? Is it up? What's happening? Step 2, I'll always tell you to find the y-intercept. Okay? Step 3, I'll tell you to find the x-intercepts. This usually is the most involved step because you're going to have to factor, or you're going to have to go through some steps to get that. Step 4, I'll always tell you to find some additional points on the graph just to, give us a better feel for where the graph is going, and then you're always going to graph it. One point that I have down here, so the maximum number of turns should be n-1 turns. So if it's x to the 3rd power, there should be 2 turns. Okay, so that means a maximum and a minimum. If it's x to the 7th power, there should be 6 turns. Okay? So, let's look at what we have here. Oops, sorry, paper got stuck. Alright, so here's our steps. So step 1, determine far left and far right behavior. So, since it's x cubed, I got a piece of paper stuck in there. Since it's x cubed, that means that my left is going to be down and my right is going to be up. And that's because it's got that odd power. Remember, my graph's going to look something like that. Find the y-intercepts. So to find the y-intercepts, I set x equal to 0. Well, if I set x equal to 0 in this problem, everything is 0. So x is 0, y is 0. So my y-intercept is 0, 0. So if I want to, I can now go to my graph and I can put that 0, 0 on my graph. Okay, find the x-intercepts. Well, in this particular problem, I can factor. I have an x in all the terms. So I'm going to factor out that common factor of x, and I'm left with x squared minus 4x plus 4. So remember, if I FOIL this back in, x times x squared is x cubed, x times -4x is -4x squared, and x times 4 is 4x. Now this part right here can factor, it's a quadratic, and it would be x minus 2 and x minus 2. And so my final factors are x parentheses x minus 2 squared. So I have two roots, 0 and 2. Since the power on the 0 is odd, okay, odd. Technically it's to the 1st power. That means it's going to go through, or it's going to cross. And the power on the 2 is even, right? So since it's even, that means it's going to touch a 2, but it's not going to go through 2.